One.
Hello, everybody. This is our week 1 Thinking Critically Team Teach. So it's me, Masheka, and let's go. Next slide.
Okay. I'm sorry. I'm really
It's okay.
I always laugh when I'm recording myself for some reason. And I'm Masheka. This is our Thinking Critically presentation.
Yes, I'm Annabeth Hrdlicka, by the way. Thinking Critically. Week 1. So, question 1.
Okay. For this question, you will have to place digits 8, 10, 11, 12, and 13 to make the rule 31. And my question for you, Annabeth, is what happens if the number 8 is not in the middle?
Well, while looking at the counter example, you can see what would happen if number 8 isn't in the middle, and it cannot be solved. It can only be solved in that exact form, because when it is not in the middle, only one section will equal 31. The other section ends up equaling 34, so it just straight up does not work. You gotta guess and check to find out.
Okay.
And I have a question for you as well on this one. My question is, what was your first step to start to solve this question? What did you look at?
I got all the numbers and I used guess and check to make sure, because it also helped solving the second part of the question, which is there any other examples to solve this? If there any other answers for this question? So using guess and check guess and check strategy also helps because you can see all the possible answers you can get from it. So I use guess and check.
Okay, thank you. That's perfect. So I guess we can just go to the next one. So I have another question for you on this one. So can you add, so looking at this one, can you add all of these together and it still won't answer out? If there are any of these where that will be the case?
Yes, if you look to the third example, and if you go to the example at the top right here, top right corner, you can see that the first, the dot equals the middle number. If you look at the third example right here that we had to solve, if we go counterclockwise, or it doesn't matter which direction you go, if you go in the direction, at the end, you'll see that answers do not match up. So 2 and 3 do not equal 6. So there is some ways sometimes that it do not equals. So this is called undefined or unsolvable problem.
Okay, thank you. That's perfect. And so there's, is there another way to solve this as well?
Yes, you can use algebraic expression. Sorry, I get tongue tied a little bit. Um, you can use the last because it's easy to see. See if we're looking for 1, but we don't know, right? This is blank. We'll put s right here, so we'll be trying to solve for s. So you'll put 8 plus s equals 9, and then you try and find s. So to try and find s, you'll subtract 8 from both sides, and then you'll see that your final answer will be 1, basically. S will equal 1, and then that will go to this one, and then you'll just keep adding and subtracting and keep going.
Okay, thank you. That's awesome. So it's just pretty much checking, guessing, adding, and subtracting.
Yeah.
So I guess we can go to question 2, because that's all I have for you for that one.
Okay. Okay. And you can go first.
Okay. So for this one, my question for you is, how do you count the perimeter?
How you count the perimeter is you basically count a side that is not touching the other square. You'll just count whichever is not touching anything else. So this will be 1, 2, 3. So this perimeter will be 3, 3. This side will be 3, 3, and 3. So then you'll add all the sides together, and that equals 12.
Okay, awesome. Thank you.
Anything else?
That's my only question for you on this one.
Okay. I have a question. My question for you is, what is the case you'll be able to use multiplication?
So for these ones, it's pretty rare for you to be able to use multiplication. You usually just have to do what you said and count the boxes around. But for this one, you can use it if it is equal on all sides. So you see that for number 1, you can use that. You see they did 4 3 plus 3s. But since it's equal, they could have just gone in the beginning and just done 3 times 4. So in the future, we can look and see that. But for all the other ones, if you try to multiply it, that would not work at all. So it would be a fail.
That's a great
So it must be equal sides. So a square is a great example.
Okay.
So question 3. Or are we done with this?
It's a lot of answers. Okay, for this question, you'll have to draw the next 2 figures that from the dot pattern. I'll let you go first. Oh,
okay.
Do you have a question?
So for this question, my question for you is, how did you find the sequence?
How did I find a sequence? It'll be better if I use annotated on this one. Annotation on this one. What I did was I found a distance. So you'll see the distance is +4. Find a distance right here, and this is 7. Now, and it'll just keep continuing till this is 10. Now, at first glance, this don't look simple. It looks like it's not following the pattern. But if you add these, you'll see that these are increasing by 3. So what you do is when you add 3, it'll give you the next sequence, which will be 13, and then so on, so on. So then you'll add 13 plus 22, and then it'll give you how many dots is in the next sequence. And that's how I found it.
Okay, thank you so much. That definitely makes sense.
I have a question for you. That is, how do you know the position the dots will go in?
So the position for these dots to go in, you would, this is question 3, correct? I'm looking at my notes. Yes, question 3. You have to look at the diagram that we were originally given, and you have to really look at it and think about how these patterns are working. So you have to think about what the next sequence of dots would be. And when you do that, when you like figure out like what the next sequence would be, you always have to add it to, you add to each row, you add 1 to each row. And it's always going to be, you see that red, it's always going to be that outside row as well. So you just keep adding from that.
Thank you, that's good. And it shows in the next diagram if it works.
So it's just, you got to learn the pattern, see where it's going, and add through the outside pretty much.
Yeah, so you just basically copy the previous diagram, but then you just add another row.
Yes, of course. Thank you.
This one is list the sequence number and correspond with the sequence of part A. Do you have a question for me on this one?
I believe. No, not for this one yet.
Okay.
But do you have one for me on this one?
I don't think so. So we'll just go to the next one. Okay. Let me move the screen. Okay. Actually, that's not. Okay. This question is add 4 more equations to the list of to the right or to the left. I put to the left. The equations. And these are the equations that we need to follow. Do you have a question for me on this one?
Not on this one, but I believe the next one. Do you have a question for me?
Yes. My question is, how will you use deductive reasoning to solve this?
So, on this one, deductive reasoning is pretty much you have to use the evidence from the other ones. So you have to really think, use your mind, use your context clues. So you use the evidence from the previous sequences to go to the next ones pretty much. So for this one, as you can see, you pull up and you just keep adding on. You keep adding on those 3 since it is an obvious 3 pattern. So yes, the 3 is the pattern, and you just got to use, we see that by looking at by using deductive reasoning and looking at the other patterns from before for the dots.
So we look at the terms and add the terms. That makes sense. Thank you.
Of course.
Okay. And that's my only question for this question. Do you have a question for me on this one?
Okay. Yes, ma'am, I do have a question for you on this one. So I was wondering, how for this one did you get on the 10th term?
How to find a 10th term. But I noticed that, like I said in the previous one, I noticed that this add 4, this add 7, this add 10. And at first, that did not seem like a pattern to me. But then when I found the distance to those, I found that to find those, you had to add 3 to those. And the same number for the distance for these is the same distance for the other term. So if I know that adding 3 will give us the next term, all I have to do is just keep adding 3. So to find the 10th term, I just kept adding 3. So 1, 4, 7, 10, 13, 16, and so on, so on. Does that answer your question?
Yes, ma'am. Thank you. That's perfect.
Okay.
Okay, I guess we can go to the next slide.
Okay. Do you have a question for me on this one?
For this one, I believe I do. We're on, what question is this? Question 3?
Yes.
Well, actually, no, I don't think I do. I don't have one for you on this one. Sorry.
Okay, that's fine. Okay. Do you have a question for me on this one?
Yes, ma'am. My question for this one. Wait, no, actually, sorry, I don't.
Okay.
I have one for the next one, but do you have any for me on this one?
Yes. My question is, it's easy to solve it with the equation, but if there's another way you can solve this, do you have to use the equation to solve this problem?
Well, for a lot of these different box ones, you usually do need an equation, but sometimes you'll get lucky and you do not need one. And for this example right here, you do not need one. So you will have to you can look at the 2 plus 3 at the bottom, which will equal the 5, because you have to always remember while solving these that the middle will equal the top. So the 2 plus 3 equals 5, so that's right there. And then you do the 25 minus the 5, which would equal the 20. So that'd be in the other box. So you can solve that one without an equation. You just gotta look and add and subtract.
Oh, I think I went to the other one. Sorry. I do have another question. Was it easier to solve this one through that way, or was it easier to use the equation?
For me, either way works. Like the equation, like is set, like it's set in stone for you there. But at the same time, this one is like it's if you notice right away that you don't have to use the equation, then it would be easier without, because you just do some quick subtraction and stuff. And who doesn't love some adding and subtracting?
Okay.
So I guess my answer is if you know, then it's easier. But if you don't, then if you don't notice, then equation's fine too.
Okay. Do you have a question?
So, no, ma'am. I don't believe so.
Okay. I do have a question for you on this one. This is how will you be able to solve for Z, the middle row, if the bottom row is not filled all the way?
So since the bottom row isn't filled out all the way and they only give you certain ones, you have to use your equation to solve the bottom
It will have to use it.
box. So the equation used is going to use 4 because you have to find the distance between the two, and the distance is 4. So then you have to, after you find the distance, you plug it into the original equation. You see the original equation right there is z plus 4 with parentheses equals 27, and then you do distributive and add all that stuff up down there, and it would be 2z plus 4 equals 27 for the final equation.
Okay.
And I do not have a question for you on this one.
Okay, let's go to the next question. This question is, we have to use the process of elimination to see who is married to whom. Is there a question for you, me, on this one?
Yes, ma'am. So for this one, I asked you, how did you use these clues to answer the question?
Okay, my answer to solve this will, oh, sorry. I just keep pushing the up arrow, the things. Okay, to solve this, it's kind of self-explanatory. The process of elimination, you will have to use the process of elimination to solve this. There's no other way to solve this. The process of elimination is eliminating all the other possibilities, so you'll have the final true answer. So they do give us a key to solve this question. The easiest way to solve this will be to marry, Kitty is married to Will. So we automatically know that Kitty is married to Will. So we can put a heart in this case if they mark everybody else out, because we know for a fact that he's not married to other people. And then as we keep continuing, we'll notice that another person will be married to someone else, and then we just eliminate the other possibilities. Finally, you'll only have one section left, which is Sarah, and then you'll find out that everybody else is marked out for Sarah, and only Floyd will be left. So we know for a fact that Sarah is married to Floyd, Kitty is married to Will, Josie is David, and Anne to Gus.
Well, thank you. Perfect. So I guess you just use the process of elimination and use your context clues. Is there any question you have for me on this one?
No, I don't. I couldn't find another question for this question.
I get it. Okay, so I guess we can go to our last question, question 6. And do you have a question for me on this one?
Not for this one, but the part B, this one. Do you have a question for me?
Yes, ma'am. It may be used for part B or this one, I'm not sure. But my question is, what is the pattern that we are using here?
The pattern?
Yes, ma'am.
See, this one, I kind of use self-knowledge. We know that it's supposed to go in a pyramid section, in a pyramid form. So let me talk about the answers. What I did was I looked at the bottom, like each equation or each section they give us. I noticed that each of them give us the base. So when they give us a base, I noticed that if to go up to the next one, you just subtract 2, and then it'll just keep going. Or you can do it the other way, and you know that it'll start out with 3 for each one, and then you add 2. So what I did was either can add 2 or subtract 2. And to find out the base, you can just count how many numbers is in the equation.
Okay, well, that's awesome. Thank you. That makes a lot of sense. Do you have any questions for me? Well, actually, you have one for part B. So
Part B.
If you want, we can move on to that one.
Okay. My question is, how will you know what, let me pull up the answers. My question is, how will you know where to place the dots?
Okay, so for this one, how you would know is you have to look at the
direction. I'm sorry. What's the direction of the dot?
Okay, for this one, you know the direction because you have to, for example, we can look at the, well, 1 by 1, 1 by 3, or 2 by 4. So you see the 1 by 3, it's just 1 times 3, the 3. And then for 2 by 4, that's a better example because you see the 2 rows and then the 4 columns. So you have to remember while doing this that there will always be more columns than rows. So that's how you see like the 2 by 2, 2 by 4. I mean, you have the 2 columns of 4 rows, and yeah, you just have to pay attention. That's how you know the directions of the dots. You just have to pay attention up there and always remember the fact that there will always be more columns than rows. So that is the answer.
Thank you.
Of
I believe
course.
that's the end of this presentation.
Yes, ma'am. Everyone, thank you for watching. I
Thank
hope
you.
everyone enjoyed. Thank you, Masheka.
Thank you, Annabeth.
Of course. And then